So we want to see a regression line is just giving the relationship between two variables. So you know the equation of a line, y is equals to mx plus c. That is the equation of a straight line, isn't it? Now, in your in regression, the constant c is denoted by a and the gradient m is denoted by b, isn't it? Then it is written in the form y is equals to a plus bx. This is the equation of the regression line. Are we together? Meaning a regression line is a straight line, isn't it? Because it is from the equation of a straight line. So your c is the a and your m is the b, isn't it? So this is the equation of a regression line. This is now said to be a regression of y on x. If y is the subject, it is y on x. Are we together? Yes. Then you can as well also write the regression line of x on y, meaning you make x the subject. If you are making x the subject, you simply interchange. Sendio? So x on y will be x is equals to a plus by. Where there is y, you put x. Where there is x, you put y. So this one is what? This one is regression of x on y. So if x was mathematics and y was physics, then you'll be told to find the regression of mathematics on physics, meaning you must, x is for mathematics, isn't it? And y is for physics. So this is mathematics on physics. This is physics on mathematics. Are we together? Is that okay? Yes. So this is the regression of y on x, equation of a straight line, okay? This is the regression of x on y. So let us start with the first case, the regression line of y on x. Let us start with that case. We've seen how it is coming about from the equation of a straight line. Regression line of y on x is given by the equation of a straight line y is equals to mx plus c, which is denoted as a plus bx. Now, this can be solved by what is referred very easily by what is referred to as the method of the least squares method. The method of least square or least squares method. Are we together? So how do we use the least square method? How do we use the least square? The least squares method to find the value of a and b so that we are able to get the regression of y on x. If y was mathematics values and x was y values, if you are told if x is 30, what would have the students scored in physics? Meaning you must know the value of a and b so that when you substitute the x value, you are getting the whole of that to be a y value. Are you seeing that? If the student scored 20 in mathematics, if x is mathematics, if the student scored 20 in mathematics, what should be expected result of that same student in physics? This regression line gives you the relationship. Are you seeing that? Such kind of linear relationship. So the least square method, the first thing you do, here we have y is equals to a plus bx. The first thing you do, you multiply both sides by summation. If you multiply both sides by summation, everything by summation, what do you get? You start. When you multiply summation of y, so you just remain with summation of y the way it is. Are we together? Then what is summation of a? Remember, when you are comparing the scores of marks of one student, maybe this is a class of 30 students. Each and every student has his own own marks in physics and mathematics respectively, isn't it? So it means when you are now going to get the summation of a, when you are going to sum all these a values, meaning there are number of students, isn't it? If there were 10 students, you are going to sum this 10 times. A plus A plus A plus A 10 times, which is the same as 10A. But now in that we don't know the number, we are going to sum A n times, isn't it? So when we sum A n times, we get A n, isn't it? Isn't it? Because we've added a n times, a plus, a plus, a plus, a plus, up to the n one. We don't know how many were they. Were they 10? Were they 20? Were they 30? We know that they are n, isn't it? So if you add that n times, it is like multiplying a times n, isn't it? So you've gotten rid of the summation, isn't it? But here you cannot get rid of the summation. We have x, meaning b is a constant, comes outside, isn't it? So it is an plus b summation of x, and that forms equation 1. Are we together? So that is a case when we multiply both sides by summation, isn't it? Now the next one, remember this is the equation. The next one, the first one, we just multiply both sides of this equation with summation. For you to get the next Roman, you just multiply both sides of the equation by summation x. Are we together? You multiply both sides of this equation by summation x, meaning summation x will multiply each and every term, isn't it? Isn't it? So here summation x times y, you get summation x times y there, then here it is summation x times a, this is summation x times y, summation x times a, then plus summation x times bx. Summation x multiply both sides of the equation. You get that, isn't it? Are we together? So what do you end up with? See here you have x times y is just xy, isn't it? Then summation of x times a, see that is ax. See a is a constant, is factorized outside. So you have a summation of x, isn't it? Then it is plus, see b is a constant, is factorized outside. Then it is b, x times x. See that is summation of x squared. See that is the second part, equation 2. Are you seeing that? So what have you seen that? Meaning regression of y on x is given by what? Y is equals to a plus bx, where if you multiply both sides by summation, you get summation y is equals to an, because if you sum an times it is an, isn't it? Then plus summation b, you factor outside, you remain with summation x there. That is the equation 1. Then equation 2, you multiply both sides by summation x. Then you get summation xy there. Summation xy to be equals to a, you factorize a outside, then you remain with summation x. Are we together? Yes. Then it is plus, you factor b outside, you remain with summation x squared. So the only two things you use is first time you multiply by summation alone, the second time you multiply by summation x. Whether it is y on x or x on y, it is the only two you use to get the two equations. Are you seeing that? Whether it is y on x or x on y, as we are going to see, you must use these two only. Okay? Are we together? Are we together there? Now what about when you now have a case? So it means these two equations are simultaneous. So the moment you are going to solve these simultaneous equations, because you have the x and the y values, meaning all these are known values, you will only remain with a and b to be unknowns, meaning you will have two simultaneous equations, isn't it? To solve the simultaneous equation, the easiest method will be what? The Cramer's rule. The Cramer's rule will take it just one step, as we are going to see, isn't it? The Cramer's rule will just be one step. Now look here, how you are going to deal with this. All these values are going to be known. Then we will form that matrix. We will see that when we are now dealing with an example, okay? So that we see how that matrix is coming about, the determinant of that matrix. Okay? Good. Cramer's rule is the simplest. If you don't like Cramer's rule, you can use substitution or elimination. Whichever method you feel comfortable with, isn't it? Now, if you look at the second case, regression of x on y. Regression of x on y. So, regression of x on y, then it means x will be a plus b, by, equation of a straight line, isn't it? That is x on, you simply interchange. Where there was y, you put x, where there was x, you put y, isn't it? Are we together? So when you are using the method of least square, the first thing you do what? You multiply both sides by summation, isn't it? So you will get summation x is equals to an. If you sum an times, you get an, isn't it? Then the plus b, you factor outside, you remain with summation y, isn't it? You know, here you've got a rate of summation to get n times, isn't it? The other one, summation is still there. See there? Then the next one, you multiply both sides by summation. Summation? Summation y. It is summation y. Because I need the xy, isn't it? It is going to be summation y. Not all of them will be summation x as you were saying, isn't it? Because I need xy here. Are we together? So you see, let me now make it more simple. Whether you are multiplying both sides by summation y or summation x, it doesn't matter. So you will still get the same answer. What matters is when you are told to find the regression of y on x and regression of x on y on the same question. Because you are going to feed the same values in the calculator, isn't it? So it means when you are getting summation xy for both of them will be convenient, isn't it? But now when the question is just dealing with y on x, it doesn't matter whether you are multiplying all through by summation x or summation y. You get the explanation. But now if you have two of them, both of them in the same question, so it means when you multiply by summation y, you still get summation xy here, which will work for both of them, isn't it? So your choice of what you are multiplying on both sides depends whether there are two regression lines on the same question. If it is a single regression line on the same question, you multiply with whichever. There's no closed fact there. All we need is to solve for the value of a and b. Are you getting that? So if you multiply both sides by summation y, you will get summation xy here, isn't it? See, summation y times here, you get summation yx, which is the same as summation xy. Just like in the other case, isn't it? Very good. Is equals to, then you factor outside a summation y, isn't it? Are we together? Then you move plus b summation y squared, because this is going to be summation y times by. B you factor outside, you remain with summation y squared. So when you multiply by summation y, it looks more neat. Are we together? You multiply by summation y, so xy, summation y, and summation y squared. So that is regression of x on y with the least square method. So the first thing you have to know, how to write a regression line. The second thing you need to know, how to determine the values of a and b with the least square method, isn't it? Let us check the first example to digest on this concept. Example 1.